Hello there. In this video we're going to go over one of the special cases of GA where you have a linear equation and an inverse equation and some inequality. So first thing we're going to do is graph it. So the line 2x plus 1, that has a y-intercept there at 1. It's fairly steep. That's going to be going up like that. Oh, that's that one. And the other one is inverse 2 over x, so that's going to, it's positive, it's in quadrants 1 and 3, it's inverse, it's going to be doing something like this. And this is just a very rough sketch, but it's giving me the idea that they intersect down here in quadrant 3, and it looks like up here in quadrant 1. Now how far forwards and backwards, that's what we're going to figure out by doing the next part of GA, the algebra. And multiply through by x. Subtract the 2, and we can try setting this one up. Multiplies to -4, adds to 1. There's actually no combination that's going to do that, so this looks like a quadratic formula problem for us. Make sure when you're setting up quadratic formula to use parentheses around these, so you can see that it's 4 times 2 times -2, not 4 times 2 minus 2. It sometimes happens. And then when I do this part, I scan through, I look for all the negatives. There's 2 of them, so the whole thing's going to be plus, and that's going to be 8/16 all over 4. So -1 plus or minus the square root of 17 all over 4. And I wrote that kind of weird looking. This here doesn't reduce anymore. Root 17, 17's prime, so that's already simplest radical form, and you're done here with the 1 and the 4. So that's where they intersect. And this one over here, that's at -1 minus root 17, the smaller one. And this one over here, that's at x equals -1 plus root 17 over 4. And we could get a decimal approximation of those if we wanted. But now we're done with the algebra. We figured out where the solutions occur, at least as far as x goes. I'm not actually interested in these intersection points from a coordinate perspective, so I don't need to plug it back in and get the y. That'd be a little bit icky to put root 17 in there. I'm interested in solving the inequality, so we're going to move on to graph, algebra, analyze. We're going to move on to analyze. And I need to know where the line is producing larger outputs or y values than this inverse one. So if I look way negative, like over here, the inverse is producing numbers kind of close to 0 on the negative end, and the line's negative something pretty big, so it's not going to be there. Here they intersect, and right after that, I'm going to get that the line is producing y values bigger than the inverse, and that's what I want. But here at 0, it kind of switches. And right after that, in the positives, the inverse is dropping in from positive infinity, and it's much, much larger. So it doesn't actually switch back. I don't actually shade anything again until over here. And that's where the line is, again, producing larger y values than the inverse. And you could test some numbers out here. If you put in like 100, you're going to get 201. Is that greater than 2 over 100? Yeah, it is. So you would shade there. Trick's realizing that you're shading this little region here and this region here. And then the final trick of it all is realizing that at 0, this one is undefined. That would be 2 divided by 0. So let's get the number line. Intersection up to 0 doesn't happen there, open circle, and then it's going to happen again and on forward. So our solution to this is going to be the region closed bracket -1 minus the square root of 17 over 4 up to 0, but we're undefined at 0, so that gets a soft bracket, unioned with -1 plus root 17 over 4 on up to infinity. That's the interval notation, and we can also write this as -1 minus root 17 over 4 less than or equal to x less than 0, or x is greater than or equal to the positive one, where it picks on up. And there we got our solutions. That was a special case. Thanks for watching. Character and Scholarship for Life.